Hey y'all, this will kick off a playlist of review problems for Chapter 12, just some random ones I picked, and when we finish Chapter 12 and Chapter 13, I will end up doing some more review problems. This is Chapter 12 review. Okay, so I think this is maybe a fundamental problem. I have it in my notes labeled as 1270. If you want to try to find where that comes from, let us know. Okay, so they give us the velocity as a function of time, and they want us to know what the displacement is from 1 to 3 seconds. So velocity is 3 in the I direction plus 6 minus 2t in the j direction. And that's all in meters per second. Okay, they say if r is 0 at t is equal to 0, that is our initial conditions. What is the displacement? That would be our delta r from 1 to 3 seconds. Okay, well, let's go to our definition of velocity. It's equal to the derivative of, velocity is derivative of position with respect to time, because we want to get to a position function. Separating variables, I get dr, and this is actually all vectors. Dr is equal to v dt. And we can do the whole vector instead of doing each component separately. Just make sure you hold on to the i's and the j's. So I'm going to integrate dr from r is equal to 0 right here to some r, and then I will integrate from some t is equal to 0 to some t and get a generic equation. I'm not going to integrate to limits because I want to know what happens at 1 and at 3 seconds. Okay, the thing we're integrating is 3i plus 6 minus 2t in the j direction. Hold on to those vectors. Okay, integrating and evaluating at t is equal to 1. And that's still a vector. We get 3t in the I direction plus 6t minus t squared in the j direction. And I knew that was about to happen. The AC just turned on. Okay, evaluating this at t is equal to 1, I get r at 1 to be equal to 3 times 1. I'm just going to go ahead and write the final product. And then if it's a position, this would be in meters. This would be meters per second. And we need to do the same thing. We need to take this and do r for t is equal to 3 seconds. And don't know what that is. Doing so will give us 9i plus 9j. Okay, what did it initially ask for? It asked for the displacement. So let's get out our definition for that. Displacement is delta r, and that's moving from some r at t is equal to 3, some r final, minus r initial. So called those are t is equal to 3 and t is equal to 1. So literally put those down in there, we get 9I plus 9j. It's in meters, and then we subtract the vector at 1 second, which is 3I plus 5j. And just add like components, and we get delta R as 6I plus 4j. Okay, so if it asked for a position at 1 second, that would be this. Position, or that would be this. That would position at 3 seconds, that's this. But since they asked for displacement, we have to take the difference between those two position vectors. So back to one of your first definitions.